So in this question, we're told that S of t is a position function of a particle that moves on a horizontal line. So there's a particle, again, moving back left and right. Find the velocity and acceleration functions. So we know that a velocity function is the first derivative of a position function. So in this case, it would be 12t cubed minus 24t squared. The acceleration function is always the second derivative of a position function. So in this case, this would be 36t squared minus 48t. Next question is represent the motion during the indicated time interval with the graph. So we really need to know first, when is the velocity equal to 0? So if we take the velocity function and factor out 12t squared, we'll end up with 12t squared times t minus 2, and that will equal 0 when t equals 0 and t equals 2. If we look at the acceleration function and factor out 12t, we'll be left with 3t minus 4. And this will equal 0 when t equals 0 or when t equals 4/3. I'm going to set some sign analysis up for both of these. So there's velocity, here's acceleration. Velocity is 0 at 0 and at 2. And I know that if the velocity was 1, then it would be a negative velocity. If the velocity was negative 1, then it would also be a negative velocity. And if the velocity was 3, I would have a positive velocity. So the particle is moving to the left, stops, keeps moving to the left, stops again, moves to the right. Its acceleration is 0 at 0 and at 4/3. When the acceleration would be negative 1, the acceleration would have a positive value. When the acceleration would be 1, the acceleration would be negative. And when the acceleration is 2, we would have a positive acceleration. So the particle is accelerating to the right, then accelerating to the left, then accelerating to the right again. And so this tells us some things about our graph. So at least at the beginning, I know that the particle is moving to the left, stops, moves to the left again until t equals 2, stops again, and then turns around and moves to the right.